So in this video, we're going to talk about the haloform reaction and specifically a haloform reaction test. These tests for methyl ketones. So these tests for methyl ketones. Okay. Okay. Now, so if we want to add an alkyl halide to a methyl ketone, then there's several considerations we got to take into account. So let's use the haloform reaction. So if I take, let's say, acetophenone, okay, here's our CH3. If I take acetophenone and I add I2 and in base in OH minus, I will get this reaction will actually go, okay. This reaction will actually go, and I'll eventually get I3. Okay, so I'll get I3 substituted for all the three hydrogens, so CI3, yeah, plus iodoform, which is a yellow solid. Okay, so a test is for methyl ketones. Test for methyl ketones, and once you get iodoform, we know that we have a methyl ketones present, and the mechanism simple goes like this. Okay. We have the ketone, we have the carbon that has three hydrogens, okay? And so what will happen, hydroxide will come in, act as a base, take off one of these, use one of these to form a double bond, and we kick off those electrons on the oxygen, okay? So if that is true, we get to a structure that looks like this. With oxygen that's negatively charged, we have the double bonded carbon-carbon double bond with two hydrogens now. Okay. Now in the second step, I2 will come in. So it will come in, and these electrons will come down, form the ketone, and use this as a nucleophilic attack. Grab the iodine and expel the other iodine atom. Okay. So in this case, we get this. We have our ketone. And now we've substituted, we have the carbon that has an iodine and has two hydrogens. So what we essentially did was substitute a iodine for a hydrogen. And actually this will continue. Yeah, so hydroxide will come in again and take off one or more of these hydrogens, and the reaction will continue until we eventually get to a structure that looks like this that we just predicted. The carbon that's bonded to three iodines. Okay. And we'll get the iodoform, which is a yellow solid. Okay, and these tests for methyl ketones. Now, if we had not a methyl ketone, but if there was a structure like this is not a methyl ketone anymore, and so this will test negative. This will test negative for the haloform reaction. So here's a consensus: base does not work with these types of chemistry. Okay, if you want to get addition onto a ketone, a methyl ketone, if you want to get addition onto a methyl ketone, we got to run it in acidic conditions. Okay, so what's the idea? If I take the same molecule, which is acetophenone, if I take acetophenone, yeah, we run it in acidic conditions. So typically we'll use acetic acid in the first step. Okay. And these electrons on the oxygen will actually attack the hydrogen and give that a negative charge. And so it will actually gain protonation. So now the oxygen has 3 bonds plus 1 formal charge. Yes, so it will gain protonation. Now what do you guys think will happen in the next step? Well, it so happens that we actually just created a really strong base in solution. Okay, really just create a strong base in solution. And so what it's going to do, it's going to deprotonate. So we have an O minus. So it's going to come in and deprotonate one of these hydrogens, take the bond, form a double bond, and put those electrons on the oxygen. Okay, so in that case, we come to a structure that looks like this. There is our alcohol now. Yeah, this is now a double bond, and we have two hydrogens. Now what's going to happen in the next step? Let's add Br2. So if we want to add an allergen to a methyl ketone, then we need to use acid, which is exactly what we're using. So this will now come in, form a double bond, and this double bond will act nucleophilic and attack the bromine atom. Okay, and displace the other one simultaneously. So now we have a structure that looks like this. There's our ketone, and this is now bonded. This carbon now has, this is a carbon that has 2 hydrogens, okay, and it's now bonded to the bromine, okay. So let me redraw the structure. So now the structure looks something like this. There's our carbon-carbon double bond, there's our CH2, and there's our bromine. So there's the addition. So if you want to get addition onto that methyl ketone, then we use it in acid, okay? So what if in an exam you're given to make this compound? Yeah, how would you make it? Make this. Okay, how would you make it? Well, if I cut this off, I could get a methyl ketone. So therefore, if I use this, you know, if I use this molecule and add Br2 in acetic acid, yeah, if I add Br2 in acetic acid, then I get the desired product. There's my bromine, and there's our group. Okay, so if you want to get the halogen added onto the methyl ketone, then we just use some sort of halogen, I2, Cl2 in acetic acid, and we'll get the desired product.